Welcome to a quick tour of how you'd use Kerfed to help you get this robot made. So this is a pseudo-holonomic active suspension ground robot based on hub motor bike wheels, a whole bunch of bent sheet metal parts, a bunch of flat parts in both this timing belt based vision system and this cyclodal drive based face arm. So yeah, there's a bunch of flat parts, parts of the countersinks, bent welded tub. So usually in order to make an assembly this large, there's a lot of custom parts going on here, but usually what you'd do is you'd make drawings for every single part. And for some of the complicated parts, I would still do that, specifically the cyclodal drive discs. But for pretty much all of the other parts in this assembly, they're just designed to be water jet or bent. So what you would do with this is you would save the entire assembly, including all of the garbage, all of these motors, all of these bushings, all the other crap. And then you go into Kerfed, and then you would drag and drop it into the quote widget. And when you upload this to a secure cloud bucket, what Kerfed is going to do is it's going to algorithmically look at every single part and determine if it's a flat part, if it's a bent part, or if it's a commercial part in the database. And then what it's going to do is, if you place the order, it's going to send the machine-ready DXFs to the machine shop. So basically, it makes this easier for you as a machine designer and easier for the machine shop to get these parts made. So the first thing that popped up is a whole bunch of commercial parts out of the database. So it actually did a geometric search on all of these parts. You can see it identified a bunch of washers. Scroll down, it's getting more. A bunch of dowel pins. You can see this part name is pretty useless. But it found a correct part name anyway. And you can see that it also counted the quantities correctly. And it's actually billing you by, this is probably 3 or 4 packs, and it's billing you by the correct number of packs of these. And then for the flat parts, you can see that they're billing based on billable area and estimated cycle time. So what it's doing is it's automatically calculating the correct cycle time for the part based on the machine. It's going to make this one with a water jet. Actually, if it was a little bit thinner, it would probably automatically select a fiber laser. Like for example, with this part, you can see the cheapest way of making it is a kilowatt fiber laser. But if you went a little thicker, the algorithm would automatically change it to a water jet. But this is a 1/4 inch part. So yeah, for the bent parts, it automatically flattened them and pulled the bend lines, made these proof drawings you can look and verify. Also always collects the quantities correctly. Yeah, for the welded parts like this, you can see that also it detected a bunch of seams that were close to each other. And it gives you the option to have those welded. So if you select the seams, when you place the order, it'll go directly to a shop with the welding operation specified. Let's see what else. The other post-processing operations, like you can see this part was designed with countersinks on 6 of the holes. And countersinks are selected by default because usually people don't drop parts with countersinks and they don't want the countersinks. So you can see it's automatically billing you for a 385 diameter, 82 degree countersink. But you can deselect it if you want it to be unspecified. And it's billing that at a manual labor rate, not at the kilowatt fiber laser rate. Yeah, so there's a whole bunch of parts in this assembly. If you're actually making them, you should go through this more carefully and look at all the proof drawings. But for the purposes of this demo, you can basically upload this whole complicated assembly, create an order, and then put in a credit card and get these parts directly in the hands of a machine shop very quickly. Thanks for watching.